Hi, my name is Tara Hartson, and this is a short video on surveying and how it relates to mathematics. I'm a professional land surveyor, and I work for a small company called HERRICK Salsbury Land Surveyors. We have offices in Ellsworth and Northeast Harbor, both in Hancock County. Boundary, or land surveyors, determine property lines and help determine the exact locations of real estate and construction projects. To do this, we rely heavily on mathematics, but also a bit on our own detective skills. This is our office staff. On the top right is Steve, the company owner. He's running a GPS. On the bottom right is Dan. He's one of our survey technicians. Then there's Tyler, who's another survey technician, and Ben, who's one of our licensed land surveyors. And we have two office staff, Stacy and Lisa. One of the things I really enjoy about my job is being able to go into the woods and find clues as to property corners and property boundaries. One of those clues is stone walls. Surveyors love stone walls. They give us an idea as to how the property boundaries are on the ground. Another thing that's really exciting to find are remnants of old wire fence. This is a stump of a tree that got cut off. The forester must have noticed the wire fence below it and probably didn't want to dull his blade, or maybe wanted to preserve and prove where a boundary line may be. As you can see, there are pieces of wire coming out of it. The tree grew around an old wire fence that has since rotted and fallen to the ground, leaving behind these little stubs, giving us clues as to where a property boundary may be. This is a picture of two purple vertical stripes, and although a land surveyor would never leave these marks behind, if they found them, they'd be pretty excited because they would know they were pretty close to a property boundary line. The stripes were probably painted on a tree by a landowner, and they signify a no hunting, no trespassing area. This is a circle of stones with a cedar post shoved in the middle. This is an example of an ancient corner marker. The next picture is the same thing, only instead of the cedar post in the center, there's a granite monument. You can see the flag around it. The next picture is a pipe, probably more familiar to you. It's a corner marker. It happens to be near an old wire fence. Wire fences are also something that we enjoy finding in the woods, as they also give us clues as to where property boundaries may be. The next picture is a wire fence that was obviously once standing up straight. As time has gone by, the post has rotted at the base and it's fallen over. In wartime, the fence will be obliterated as leaves fall on top of it, and will only be found by a metal detector. The next picture is a wood post. The PC stands for Prentice and Carlisle, the company that set the post in the ground. It marks a property corner. Here in the final picture is a piece of granite on the shore. If you look closely, there's a B engraved into the granite. When we start a new survey job, oftentimes we start in the office or at the Registry of Deeds reading descriptions of land. This is a description of land out on Cranberry Isle and a job I just recently completed. It calls for a stone bound in the beach marked with a B. If you look at this image, it is the stone bound. If you look closely, you can see the B carved into the rock, and we found it. It was an exciting moment for sure. Also, in the description is a call for another stone bound marked B. When I paced up to where I thought that B would be, I didn't see any rocks or anywhere to carve that B. So on a second visit to the site, after I'd picked up some other points and been able to draw the geometry of the deed description on my computer, I had better search coordinates as to where to dig for the second B in a rock. In this picture is my GPS over that B. I dug down about a foot and found that B right there, preserved in the rock. Using geometry and detective skills paid off. This is a survey plan, and it's the final product we produce for our clients. It shows our final survey answers on a piece of paper for them. It shows their boundaries, and they're always interested in how many acres those boundaries may enclose. This image shows all of our field work and our computer work all in one product. Surveyors are involved in many different areas of life. Early surveyors and current surveyors have a lot to do with map making, so here's a picture of a topographic map that surveyors absolutely had an impact on. More local to our office, we do a lot of work for land conservancies, and we do a lot of work for building layouts. Here's a picture of the Ellsworth Middle School. We laid out the foundation corners quite a few years ago now for that building. There is a cell tower pictured here. Often cell towers are on leased land. We prepare descriptions of those leased lots so that the cell towers can go ahead and make an agreement with the landowner and put their tower on them. We work with alternative energy companies, some with wind farms shown here. We also have laid out runways. My first day on the job as a land surveyor, I was in the Bar Harbor Airport laying out the runway. That was pretty exciting. We do a lot of work with gravel pit owners, whether it's on the permitting end or figuring out how much material has been taken out of the pit for cost. We do a lot of different types of work for sure. Even if surveying maybe doesn't interest you, it does impact your life. I don't know that anybody can live in this world today without the impact of the work of a surveyor. The final picture is, as you might recognize, Mount Everest, and in the front of the picture is a man. His name is Mr. Everest. He was a land surveyor, and he was the first person to determine the elevation of Mount Everest. Surveyors like triangles, although technology has advanced through time. Our dependence on triangles has never changed. And the keynote here is that all I learned in high school in my math class is the foundation of the math I need to perform my job as a land surveyor. When it comes to Maine, we have a pretty neat historical landmark. It's called the Epping Baseline. There were 6 of these baselines constructed. The Epping Baseline is the only one that still exists today. It's in Cherryfield, and you can go visit it. It's basically a long, straight road in the middle of a blueberry field. And here's a quick overview of what it is. So there's monuments at either end of the Epping Baseline. Stone monuments were set to mark both the east and west endpoints. The square granite base of one of these historic monuments is still there, and the marble obelisk that marked the western endpoint is now preserved in the Maine State Museum in Augusta. This is a historical picture showing how the surveyors back in the day measured the length of the Epping Baseline. Their tools were very different from ours today, but their distances were still accurate. From the Epping base, surveyors were able to extend a network of triangles upon triangles that span down the East Coast region. This is a map of the triangulation stations around Hancock County. The green line is the Epping Baseline. It was very much tied into all the other triangulation stations at the time. Triangulation stations were generally high points on the ground that could be seen from afar. This is a map showing triangulation stations going way further south than just Maine. The brass disc pictured here shows a triangle in the center. It's representative of a triangulation station. If you're hiking around on mountaintops or exposed ledges on the eastern seaboard, you may find some of these brass discs. And the ones that have the triangles in the center do designate that they were historical triangulation stations. Historically, for the land surveyor, turning angles was easier than measuring distances. If the surveyor knew one distance and 2 angles, all the other parts of the triangle could be solved. This is called triangulation, and that was the whole point of the Epping Baseline. In this triangle diagram here, the lowercase b is representative of the Epping Baseline, and the angles at uppercase A and C are the angles that were turned from the east and the west endpoints to point uppercase B, another triangulation station. Therefore, the Epping Baseline, the lowercase b, was a known distance, and the angles at uppercase A and C were known, and all other parts of the triangle could be solved. Our equipment today is a little more advanced than the equipment used by surveyors historically, but our equipment still achieves the same things. Pictured here is a total station and data collector. The total station locates objects with an EDM. EDM means electronic distance measurement. It shoots a beam of light out to a surface, and the reflection returns and time is calculated. A distance can be figured from that. The data collector on board this instrument configures horizontal distance using triangle geometry. The other equipment shown here is GPS. We use GPS for our work more and more. GPS relies on trilateration, which is a little different than triangulation, even though triangles are still the prominent thing. All methods, new and old, depend on triangles. Here's a short movie explaining trilateration.
At over 20,000 kilometers above sea level is a constellation of satellites, each orbiting Earth every 11 hours and 58 minutes. These satellites are continuously beaming data down to us on Earth, which is in turn received by devices such as your phone or navigational units in your cars, allowing you to see where you are on the planet. There are a lot of misconceptions about how GPSs actually work, an example being that your phone and the GPS satellites are both talking to each other. So let's get down to it. How do GPSs work? GPS stands for Global Positioning System, which works through trilateration, not triangulation or multilateration, which is commonly misconceived. There are many different types of navigational satellite systems from countries across the world, but the most popular and commonly used system is Navstar, which is the USA system. There are, however, Russian, Indian, Chinese, and European equivalent systems, although the Indian and Chinese systems sit in a geosynchronous orbit above their countries, which means they are not worldwide systems. The Navstar system, which is simply referred to as GPS, is what we will be focusing more on, although most phones and devices tend to have the capabilities to use both GPS and GLONASS. GPS satellites are set up in such a way that from almost anywhere on the surface of Earth you should have a direct line of sight of at least 4 GPS satellites. This is quite important on the basis that GPS point positioning requires at least 4 satellites to calculate 3 position coordinates and the clock deviation. As GPS units are receivers, there needs to be something sending some sort of signal to devices such as your phone to receive. Each GPS satellite broadcasts a navigational message towards Earth which contains an extremely accurate timestamp, which is obtained through an atomic clock which is on board these satellites. And the satellites also broadcast their position at the time of broadcast, with all GPS signals broadcasting at 1.5752 GHz and 1.2276 GHz. These 2 bits of information allow you to work out your position on Earth. With these satellites all sending exceptionally accurate time down to Earth, your phone or GPS receiver can compare the difference of time between when the signal was sent to when it was received to work out the distance between you and the satellite. By multiplying this time difference with the speed of light, as the signal is sent at the speed of light, you can begin to get the distance away you are from that satellite. As these satellites are also sending whereabouts they are, you can begin to draw spheres around the satellites, with you being somewhere on the outer border of that sphere. As we introduce more GPS satellites into the mix, we begin to get closer to where we are. By calculating the time differences between these satellites, we move from having no idea where we are to being able to pinpoint where we are, typically down to 5 to 10 meters on average, with the potential error being around 15 meters.
Thank you for your time. I hope you enjoyed the presentation. If you want to find out more information, we have a website. You can visit us at www.herricksalsbury.com. You can reach out to me with any questions at tara@herricksalsbury.com. Thank you for your time. I hope you learned a little bit about triangles and surveying.